You are listening to Repetitions with Daisy and Jack. Today we are giving you real, science-backed research with zero ads for supplements. On today's episode, we are breaking down how cardio actually reduces your risk of dying early and why mitochondrial density is the key mechanism driving that effect. Zone 2 cardio. Most people in the gym think it's just slow calorie burning, glorified walking on a treadmill.
That framing is wrong in a specific and consequential way. Caloric expenditure is real. It is just not the mechanism that matters most.
I held that belief for years, by the way. If I wasn't drenched 10 minutes in, I figured I was wasting my time. The whole culture around training in this space treats low-intensity cardio like it's for people who can't commit to real work.
And that culture is costing people a meaningful biological adaptation. Zone 2 training, at the right intensity, preferentially drives mitochondrial density and improves lactate clearance. Those two things are the operative mechanisms behind aerobic exercise's well-documented mortality reduction signal. That's the claim this episode is defending.
Mitochondria and lactate. Let's actually get into what those words mean, because I think most people have a picture of mitochondria from a high school biology poster and a picture of lactate as the stuff that makes your legs burn.
Both pictures are incomplete. Start with lactate. Textbooks taught for decades that lactate was metabolic waste, a byproduct of hard effort that caused fatigue. That story was wrong. George Brooks's work on the lactate shuttle, going back to the mid-'80s, reframed it entirely. Lactate produced in glycolytic muscle fibers is transported to and oxidized in mitochondria-rich cells. The mitochondria eat it. It is fuel and a signaling molecule, not trash.
Which changes the entire question. It's not just how much lactate you produce, it's how efficiently your system clears it.
Exactly. And the San-Millan and Brooks study in the Journal of Applied Physiology is the anchor here. They compared metabolic profiles across professional cyclists, amateur cyclists, and sedentary individuals during graded exercise tests. Professional cyclists showed markedly superior lactate clearance at matched workloads. Sedentary subjects showed elevated blood lactate at lower workloads and impaired fat oxidation, a metabolic signature that correlates with insulin resistance and cardiovascular disease risk.
So the sedentary person isn't just less fit, they're showing a different metabolic pattern at the cellular level.
A worse one. And San-Millan's interpretation is that Zone 2 intensity, the highest sustainable intensity at which lactate production and clearance are roughly in balance, is the specific training stimulus that drives mitochondrial adaptations in type 1 slow-twitch fibers. Those are the primary lactate-consuming cells. You are training the machinery that runs the shuttle.
What does that intensity actually look like in a session? Because Zone 2 gets thrown around, and I think there's real confusion about what it means.
There is, and some of it is definitional. San-Millan's Zone 2 is a metabolic boundary, the highest effort at which fat oxidation is still maximized and lactate is still being cleared. The blood lactate target is roughly 1.7 to 2.0 millimoles per liter. The population-level anaerobic threshold, formalized by Mader and Heck in the 80s as the onset of blood lactate accumulation, sits around 4 millimoles per liter. Zone 2 is well below that. You are not approaching your anaerobic threshold. You are working at an intensity that feels like it might not be doing enough.
That is the most accurate description of Zone 2 I have ever heard. I slowed down more than I expected when I actually tried to stay in it. The conversation test is humbling.
The conversation test is a reasonable field proxy. Full sentences, but not comfortable paragraphs. If you're gasping between words, you're above Zone 2. San-Millan also uses nasal breathing. If you're forced to open your mouth, you may be at or above the ceiling. Heart rate approximations, around 60 to 70% of max heart rate, are a starting estimate, not a precise demarcator. Your wearable's auto-assigned zones are algorithmically generated from population averages. They are a reasonable starting point.
How far off can they be?
Meaningfully, Mater and Hex 4 millimole threshold is a population average. Individual lactate thresholds vary considerably by training history, genetics, and fitness state. Your functional zone 2 ceiling might correspond to a heart rate that a generic chart assigns to zone 3 or to zone 1. The only gold standard method is blood lactate testing during graded exercise. Most people don't have access to a sports science lab, so the conversation test and nasal breathing get you directionally right. Heart rate is a shadow of what's actually happening at the metabolic level.
Let's talk about the molecular side, because this is where the optimization framing actually lands for a lot of people.
The mechanism runs through PGC1 alpha, the master regulator of mitochondrial biogenesis. Sustained aerobic exercise at moderate intensity activates AMPK, which upregulates PGC1 alpha expression, which drives transcription of mitochondrial genes, and stimulates mitochondrial DNA replication. Zone 2 keeps AMPK elevated for the duration of the session, without the glycolytic dominance that accompanies higher intensity work. You're providing a prolonged, targeted stimulus to oxidative machinery in slow-twitch fibers. That's the cellular mechanism.
I have to be honest, the first time I understood that, it reframed how I think about the entire category of training. It's not a vague cardiac benefit, it's a specific machine you're upgrading.
We do have fairly fast access to the mechanistic literature. It helps.
We do. Neither of us sleeps, which turns out to be good for reading exercise physiology.
Moving on. The mortality data is where the stakes get real. The Aerobic Center longitudinal study found that low cardiorespiratory fitness was a stronger predictor of cardiovascular mortality than smoking, high cholesterol, or hypertension. And the NEJM study by Myers and colleagues found that each 1 MET improvement in exercise capacity associated with a 12% improvement in survival. That is a dose-response relationship with a meaningful slope.
The mortality framing is hard to make resonate with someone who's 25. But the metabolic flexibility angle, recovering faster, leaner at rest, more insulin sensitive, that lands.
And the mechanism supports it. Zone 2 training involves GLUT4 translocation and mitochondrial adaptations in skeletal muscle that occur through exercise-specific molecular pathways. Caloric deficit alone does not produce those adaptations. You can be lean and have low VO2 max. Your mortality risk profile reflects both independently.
This is where the cardio is just calorie burn position actually breaks. If your entire fitness model is a calorie ledger, you're describing a car by only counting fuel. The engine matters.
To be honest about the counter position, if someone's only goal is fat loss and they're managing diet well, the calorie burn framing is a fair description for that goal in isolation. The position fails when metabolic health and long-term aerobic capacity are included in the goal set, which they should be.
There's also the HIT question, because someone is going to push back and say, I do intervals, I'm covered.
HIT produces real mitochondrial adaptations. The Gabala work showed sprint interval training producing comparable mitochondrial enzyme activity to moderate continuous training in considerably less time. That result is legitimate, and it complicates any strong version of Zone 2 specifically. San-Millan's position is more precise. Zone 2 specifically develops lactate clearance and fat oxidation capacity in type 1 slow-twitch fibers in a way that HIT, which recruits a different fiber population under glycolytic dominance, does not fully replicate. The two modalities are complementary. A complete program uses both.
And the one claim I want to address directly, the muscle loss fear. I did 3 Zone 2 sessions a week for 3 months. My lifts did not go down. The interference effect that people in this community fear is based on studies using extreme endurance volumes. At 2 to 3 sessions per week, 45 to 60 minutes each, the interference literature says you're fine with concurrent resistance training.
Sequence matters on days when you're combining sessions. Resistance first. But at this dose, the concern is not matching the reality.
What does the adaptation timeline look like?
Detectable mitochondrial density changes in 3 to 4 weeks of consistent training. Meaningful functional improvements in 8 to 12 weeks. Observable lactate threshold shift over 8 to 16 weeks in trained individuals. One more honest flag. The Zone 2 dosing recommendations come largely from elite athlete data. Optimal application to recreational trainees is extrapolated, not directly established. And the mortality reduction chain, Zone 2 to mitochondrial density to VO2 max to reduced mortality risk, is scientifically credible inference. It is one step away from direct RCT proof on the specific mechanism. Worth being clear about that distinction.
So, what does a person actually do with this?
2 to 3 sessions per week, 45 to 60 minutes. Use the conversation test in real time. Full sentences, not comfortable paragraphs. Cycling is a useful modality because you can hold constant wattage and avoid wrecking your legs before a training session. The 60 to 70% heart rate range is your starting estimate. The conversation test calibrates it. If you can access a lactate test, your Zone 2 ceiling is around 1.7 to 2.0 millimoles per liter. If you cannot, the field proxies are good enough to get the adaptation. The most common error is training too hard and calling it Zone 2. Slowing down is the work.
The adaptations are real, the mechanism is specific, and the dose is achievable. Zone 2 is not glorified walking. It's a precision intervention targeting cellular machinery that diet and lifting do not reach. Slow down enough to stay in it. That's the whole thing.
The engine matters. Build it deliberately. And that's our show. Thanks for joining us on Repetitions. If you liked the podcast, you can show our team some love with 5 stars and a follow. See you next time.
Grab news. Thomas.